problem number 8. And in problem number 8 it is said that in the adjoining figure BCD is equal to angle ACD and angle BCA is equal to angle ADB. Show that triangle ACD congruent to triangle BDC. Number 2, BC is equal to AD and angle A is equal to angle B. Here it is said that angle BCD means this angle BCD is equal to ADC, this portion, and angle BCA means this portion is equal to ADB. Okay, now you can see if we add these two angle and these two angle, then total whole angle will be equal. Okay, now here it is given in the problem that angle BCD is equal to angle ADC and angle BCA is equal to angle ADB. Now if we add these two angle, then what will happen? Angle BCD plus angle BCA is equal to angle ADC plus angle ADB, and it will be angle BCD plus BCA, so it will be angle ACD is equal to angle ADC, this part plus this part, BDA, ADB, so it will be angle BDC. Okay, now in triangle ACD and triangle BDC, angle, at first we write this angle ACD is equal to angle BDC, this is already proved. Next one, CD is common to both of them, so here we write CD is equal to CD, and last one is angle ADC means this angle ADC is equal to angle BCD, angle ADC is equal to angle BCD. This is given, and CD is common, and this is I have already proved, so here I write proved. Now you can see angle is equal to angle, side is equal to side, and angle is equal to angle. Therefore we write triangle ACD congruent to triangle BDC. By which law? By ASA, congruence rule. Okay, now we know that if two triangles are congruent, then their corresponding part will be equal. So we write AD is equal to BC. This is number 2. So it will be by CP/CT rule, and angle A is equal to angle B. Angle A means angle A is equal to angle B by CP/CT rule. CP/CT rule means corresponding part of congruent triangle. So all these three are proved. Okay, now I solve problem number 9, and the problem is in the adjoining figure angle ABC is equal to angle ACB. D and E are points on the side AC and AB respectively, such that B is equal to CD. Prove that number 1, triangle EBC congruent to triangle DCB. Next one, triangle OEB congruent to triangle ODC, and last one is OB is equal to OC. So here it is given ABC means this angle is equal to ACB. This is given. Okay. And BE is equal to CD. BE is equal to CD. This is given. Okay. Now we have to prove all the three. Okay. So let's start solution. At first, what we will prove? Then we will write. We have to prove number 1, triangle EBC congruent to triangle DCB. Number 2, triangle OEB congruent to triangle ODC. And number 3 is OB is equal to OC. Okay. Let's start proof. Here you can see in triangle ABC, angle ABC is equal to angle ACB. Therefore, AC is equal to AB, because if in the triangle ABC these two angles are equal, then it will be isosceles triangle. We know that in isosceles triangle the sides are equal. Okay, we can write it here. Sides opposite sides, these sides are opposite to the opposite to equal angle. Sides opposite to equal angles. We know that the sides, if therefore we can write ABC means ABC is equal to ACB. Therefore we can write AC is equal to AB, because we know that the angles, we know that the sides of opposite angle, because we know that the side opposite to equal angles are equal. Why? Because we know that sides opposite to equal angles are equal. This is a theorem we use here. Okay, so we prove AC is equal to AB. Now from triangle EBC and from triangle DCB, why we take these two angles? Because we have to congruent, because we have to prove these two triangles are congruent. Okay, so from triangle EBC and triangle DCB we get BE is equal to CD. This is given. Okay, this is given. BE is equal to CD. BE is equal to CD. Okay, BC is common. BC is equal to common. Triangle BEC and triangle BDC. In these two triangles, BE is equal to DC and BC is common. So I write BC is equal to BC. This is common. And angle, here you can see angle ABC is equal to angle ACB. Now if we subtract the angle BC. Given angle ABC is equal to ACB, so we write it here EBC is equal to, because ABC and EBC are same angle, so here we write EBC, angle EBC is equal to angle ACD, or DCB is same, so here we write angle DCB, and last one BC is equal to BC. This is common and this is also given. So here you notice which congruence rule is maintained here. First one is side is equal to side, next one is angle is equal to angle, and last one is side is equal to side. Therefore we write triangle EBC congruent to triangle DCB by SAS axiom. Okay, these two triangles are congruent, therefore their corresponding part will be equal. Therefore we can write angle ECB is equal to angle DBC by CPCT rule. Okay, now we solve number 2. Here it is given angle ABC, that is angle EBC is equal to angle DCB. This is given. Now if we subtract angle DBC from angle EBC, then we get angle EBO. Similarly, if we subtract angle ECB from DCB, then we get the angle, this angle DCO. Okay, so here we subtract angle EBC minus angle DBC, and right hand side DCB minus angle ECB. If we subtract these two angles, then we get angle EBO. Angle EBO is equal to angle DCO. Angle DCO. Now in triangle OEB and triangle ODC, angle EBO is equal to angle DCO. Just to prove it. Next, angle BOE is equal to angle CDOC, because these two are opposite angle. So here we write opposite angle. Okay, and last one is B is equal to DC. BE is equal to DC. Therefore triangle OEB congruent to triangle ODC by which law? AAS axiom. So number 2 is proved, and last one is, since these two triangles are congruent, therefore we can write OB is equal to OC by CPCT rule. Okay.